Yes, in the last session we had the discovery of electrons completed and properties of electrons also completed. Today in this second session, let us start quick revision of the discovery of electrons and together properties. Then we proceed to the specific charge and determination of charge of the electrons, that is Mulligan's oil drop experiment. Okay, now the discovery of once again electrons, that is cathode rays. Cathode rays was first, the discharge tube experiments was conducted by Crookes and Plucker scientists. So the evacuated glass tube, that is evacuated discharged tube, so at normal pressures by passing high voltage, that is 10,000 volts current, so they did not observe any measurable changes in the discharge tube. When the pressure is reduced 10 to the power minus 2 to 10 to the power minus 3 millimeters of mercury pressure, they observed a beam of light or glow was observed on cathode when the pressure is reduced. Okay, so some rays are produced at cathode. The same discharge tube experiment was repeated, experimentally done, proved by J.J. Thomson, and he observed that some rays are moving from cathode to anode. Since the rays are produced at cathode, he named them as cathode rays. J.J. Thomson experimentally discovered the cathode rays in discharged tube. Okay. Then after the discovery of this cathode rays, these cathode rays are named as electrons by G.J. Stoney. The name of the scientist is G.J. Stoney. He named the cathode rays as electrons. Okay, that is a history for the discovery of cathode rays, that is electrons. Now, the properties of these cathode rays, that is electrons. So these cathode rays have, that means they travel in straight lines. They travel in straight lines because in the discharged tube, in the path of these cathode rays, when an object is placed in the middle path of the cathode rays, the shadow of this object falls on the opposite side. This indicates that the cathode rays travels in straight lines. And second point, we can say that these cathode rays has mechanical moment. That means these cathode rays possess momentum and energy, because when a frictionless metal wheel is placed in the path of the cathode rays, so these cathode particles, by hitting these metal fans, the metal fan rotates continuously. So as a result, this concludes that the cathode rays can cause mechanical moment. That means they possess momentum and energy. This proves that momentum and energy of the cathode rays. And these cathode rays, when passing through the magnetic field, they are deflected towards south pole. When they are passing through the electric field, they are deflected towards anode, that is positive pole. This concludes that the cathode rays are negatively charged particles. So this is right. Now the charge of the, that is specific charge of the electrons. The specific charge of the electrons, that is J.J. Thomson determined E by M ratio. J.J. Thomson determined E by M ratio, that is specific charge of the electrons, that is specific charge of the particles. Specific charge of the particles, that is charge to mass ratio, represents the specific charge of the particle. So the specific charge, that is E by M ratio of electrons, E by M ratio of electrons, that shows, that is charge of the electron 1.602 into 10 to the power minus 19 coulombs by mass of the electron, that is 9.1 into 10 to the power minus 31 kg. That gives 1.76 into 10 to the power 11 coulombs per kg. This is in coulombs and it is coulombs per kg. That is the specific charge of electron, that is E by M ratio. The specific charge represents, that means as the specific charge of the particle increases, the deflection in the electric field increases. The specific charge of the electron is directly proportional to the, that is magnitude of the charge on the electron, and it is inversely proportional to the mass of the particle. As mass of the particle increases, the specific charge of the particle decreases because it is inversely proportional to the mass of the particle. So the specific charge increases, that means the deflection in the electric field increases when the magnitude of the charge increases. Okay. Now, J.J. Thomson determines the value of charge to mass, that is, as velocity of the electron increases, the specific charge of the electron decreases due to increase in the mass of the electron. Due to increase in the mass of the electron, the velocity of the electron increases and specific charge of the electron, that means as the specific charge of the electron decreases. Okay. So then the mass of the moving electron can be calculated by using the formula. This is according to theory of relativity. So here in this formula, m is mass of moving electron, and m naught, this m naught represents rest mass of electron, and v is equals to velocity of electron and c is equals to velocity of light. When velocity of the electron is equal to the velocity of light, then the mass of the electron becomes infinity. The specific charge of the electron is independent of the cathode material used in the experiment, and it is independent of, the specific charge is independent of the gas used in the discharge tube. That indicates that electrons are constituent particles of all the matter. The charge of the electron was experimentally determined by Mulligan's oil drop experiment. Mulligan's oil drop experiment. In this experiment, the two charged metal plates are taken in the condenser and oil droplets are dispersed in the upper part of the condenser. These oil drops are passing through between the two charged plates through a small tiny hole. The equipment is arranged, that means it is equipped with a micrometer, that is telescope, to view the droplets on the electrical plate, and the gases present in the chamber are ionized by passing stream of X-rays. The charge acquired on the droplets, because since the two electrical plates are heated by passing high voltage electricity, so therefore the gases present in this chamber are get ionized. So these ionized, the electrons are deposited on oil droplets. So the oil droplet is coming, that is downward flowing oil drop is experiencing the various types of forces. They are such as gravitational force, electrostatic force, that is due to electric field, and that is the viscous drag forces are applicable on this. So the electrons deposited on this oil droplets are carefully viewed from the telescope. Okay, so Mulligan finally concludes that the electrical charge deposited on oil droplet is always integral multiple of electrical charge of the electron. Once again, the Mulligan's oil drop experiment, briefly let us discuss about the diagrammatic explanation. The electrical condenser is used to determine oil drop experiment, that is charge of the electron. In this, oil droplets are dispersed in the upper portion of the electrical condenser. Between the two electrical plates, that is in the upper plate, a small tiny hole is present. The oil droplets are slowly passing through the tiny hole of the upper electrical charged plate. The downflowing oil drop is experienced with the different sort of forces such as gravitational force, electrostatic force. The oil droplets are passing through the tiny hole of the upper charged plate. It is viewed through the telescope having a micrometer eyepiece. Then the gases present in the chamber are ionized by passing a beam of X-rays. During the ionization process, the electrons adsorbs on the surface of the oil droplet. The downflowing oil drop experience with the gravitational force, the electrostatic force due to electrical potential, and the viscous drag forces. Mulligan observed the mass of the electron in this experiment and Mulligan finally concludes the charge acquired, the charge present on the electrical charge present on the oil droplet is integral multiple of electrical charge of the electron. Yes. For example, an oil droplet possessing 8 into 10 to the power, an oil droplet possessing 8 into 10 to the power minus 19 coulombs of charge. How many electrons does this charge has? This is the charge present on the oil drop. So according to the Mulligan, so the Q is equals to 8 into 10 to the power minus 19 coulombs. So how many electrons are possessing this charge? So that is electrical charge of the electron, that is standard 1.602 into 10 to the power minus 19 coulombs. So therefore N is equals to 8 into 10 to the power minus 19 by 1.602 into 10 to the power minus 19, that is equals to charge of the 5 electrons. Goldstein experimentally discovered protons, that is anode rays, or they are called canal rays. So he repeated the discharged tube experiment of J.J. Thomson. So the gas that is in this discharged tube, so the perforated metal cathode is used. The gases are heated under low pressure. They are heated at high voltage by passing more than 10,000 volts electricity. So the rays, they are passing through the perforated metal cathode, therefore they are called canal rays. and these canal rays are named as proton by Rutherford. Rutherford proposed the name proton for these cathode rays. Cathode rays, in the discharge tube, if the gas is hydrogen, then the specific charge of proton will be higher. Okay. Rutherford obtained protons when nitrogen 714 is bombarded with alpha particle. Is bombarded with an alpha particle, H11 alpha particle, that is proton is produced, plus so Rutherford produced a proton when a nuclide of nitrogen is bombarded with an alpha particle. It produces a proton, that is according to Rutherford. Next, neutron. Neutron can be described as the chargeless null charged particle present in the nucleus of atom is neutron. Neutrons are chargeless subatomic particle, that we know that very well. Then neutrons experimentally discovered by James Chadwick experimentally discovered the neutrons. So beryllium nuclide or boron, when bombarded with an alpha particle, beryllium nuclide is bombarded with an alpha particle, it produces 4 plus to 6, that is a new product element is carbon 12, and the rest mass, that is the ejectile particle has 0 charge and 1 unit of mass, that is neutron. Similarly, boron 511 is bombarded with an alpha particle. This produces a product nucleate, that is 7 and 14, and the ejectile particle is a chargeless unit mass particle, that is neutron. That is the discovery of neutron according to James Chadwick. And the neutrons are null charged particles, they do not deflect in the magnetic field or in the electric field. Then the atomic models. The atomic model was first explained by J.J. Thomson. According to J.J. Thomson, the atomic model he described as the cross section of watermelon, or it is also called plum pudding model of atom. According to plum pudding model of atom, or it is nothing but cross section of the watermelon. In the watermelon cross section, we find the entire reddish mass, the fibrous reddish mass is uniformly distributed, and the black sheets are embedded in it. Similarly, in the atom, the positive charge, the mass of the atom is uniformly distributed in the entire atom, and the negatively charged electrons are embedded in it due to electrostatic attractive forces. So that is called plum pudding model or watermelon model of atom according to the J.J. Thomson. And the next one is Rutherford's atomic model. Rutherford described the atomic model as planetary motion. According to Rutherford, planetary motion model of atom. The various planets are revolving around sun. Similarly, in the atom, negatively charged electrons are revolving around positively charged nucleus. That is Rutherford's planetary motion model of atom. So he described this based on alpha ray scattering experiment. Now, the details of alpha ray scattering experiment, like In the alpha ray scattering experiment, polonium he selected as a source of alpha rays. So the alpha rays emitted from polonium are projected on the thin gold foil. The polonium radioactive element emits alpha rays. The beam of alpha rays are scattered. The scattered alpha rays are projecting on the thin gold foil. That is Rutherford experiment. Alpha ray scattering experiment. That is a thin gold foil, and behind the thin gold foil he arranged a fluorescent screen. Behind the gold foil he arranged a fluorescent screen coated with zinc sulfide. It is coated with zinc sulfide. When alpha ray, that is alpha particle, strikes this fluorescent screen, it causes scintillations. The polonium element, that is radioactive element. So the alpha rays obtained from this polonium, they are scattered and projected on thin gold foil. Thin gold foil, and here that is experiment part. Now coming to the observations of alpha ray scattering experiment. Observations of alpha ray scattering experiment. The observations of this is interesting. First observation: the most of the alpha particles passing through the thin gold foil in straight lines. Most of the alpha particles passing through the gold foil in straight lines. Passing through the gold foil in straight lines. Passing through the gold foil in straight lines. Like this. Most of the alpha rays passing through the gold foil in straight lines. And some of the alpha particles reaching to the center portion. That is the first observation. Once again, the first observation, most of the alpha particles passing through the thin gold foil in straight lines. That concludes that most of the space in atom is hollow, that is empty. So that first conclusion and first observation is done. And second observation, some of the alpha rays reaching to the center point are deviated with many angles. Some of the alpha rays reaching to the center point are deviated with many angles, indicating that concludes that the entire mass of the atom is present at the center point. This mass portion he named it as nucleus. This mass portion is named it as nucleus. Out of 20,000 alpha particles, one alpha particle strikes at the center point of atom is rebounded in its own axis. Indicates that the alpha particle, the dipositively charged alpha particle, may be repelled by the identical charged particles which are present inside the nucleus. So therefore, he also determined the charge of the nucleus as positive. And Rutherford concluded that the radius of the atom is approximately 10 to the power minus 10 meters, and he also determined the radius of the nucleus as nearly 10 to the power minus 15 meters. Once again, the short review about the experiment of the Rutherford's alpha ray scattering experiment in this: a thin gold foil, that is thin gold foil 0.0005 0.04 centimeter diameter thin gold foil is used for alpha ray scattering experiment, and he selected alpha rays, the source of the alpha rays, as polonium radioactive element. The polonium is emitting alpha rays. These alpha rays, the scattered alpha rays, are projecting on the thin gold foil. That is experiment. Observations: most of the alpha particles penetrating through the gold foil passes in straight lines. This concludes that most of the space in the atom is empty. And second observation was, some of the alpha rays reaching to the center point are deviated with many angles. This indicates that the entire mass of the atom is present at the center portion or center point. This mass portion of the atom, he named it as nucleus. And third observation, out of 20,000 alpha particles, one striking at the center point of the atom, it is rebounded in its own axis. This concludes that the dipositive helium ion, that is alpha particle, when strikes the center point, this may be repelled by the identically charged particles which are present inside the nucleus. Therefore, he also predicted the charge of the nucleus as positive. Yes, atomic number. Atomic number was discovered by the scientist Moseley. Atomic number was discovered by the scientist Moseley, and the atomic number is denoted by the general symbol is Z, capital Z. So now the definition of atomic number. Definition of atomic number. For example, let us consider carbon 612. Yes, now the definition of atomic number. Atomic number, the number of particles, the number of protons present in the nucleus, the number of protons present in the nucleus of atom or ion represents atomic number. The number of protons present in the nucleus of an atom or ion is atomic number, or the number of electrons present in a neutral atom is atomic number. Is atomic number. And Moseley also obtained a relation between root nu is equals to A into Z minus B. This signifies that the frequency of the emitted X-rays from an element and atomic number of the element. He explained the relation between the frequency of the X-rays emitted from an element and to its atomic number, and A and B are the constants for a particular element. It is not common for all the elements. A and B constant values changes. This is called Moseley equation. Moseley equation. So, based on this Moseley equation, the numericals are important for mains and advanced level examination.